Today we're going to look at operating on polynomial functions. Specifically, we're going to be doing adding and subtraction in this video. So for the first example, we have to simplify this long expression, which is the combination or addition of two polynomials, x cubed plus 3x minus 6 plus negative 2x squared plus x minus 2. So addition is really pretty simple because this addition sign does not change the value of the polynomial that comes after it. You can kind of think about it like distributing that plus to everything, and distributing a plus to anything keeps it the same. So we can rewrite this polynomial and just get rid of the parentheses to make it easier to combine like terms. Alright, so I did put parentheses around the negative 2 just to distinguish it from the plus in front of it. And now we want to identify our like terms. So now that we have this written out without parentheses, we want to look at our like terms. So we have a term that is cubed here, and that's the only one that I see. We have a term that is squared here, and that's the only one that I see. And again, so let's put a box around these. We always want to keep the sign that is in front of the term with the term. So I'll put another box around this one. We have an x term here and an x term here. And we have a constant term here and a constant term here. So if we were to combine these and put these in standard form all at the same time, going from the highest degree to lowest degree, we have one term that is cubed to the power of 3, and that's the highest. So we'll rewrite that, and we're not combining that with anything. We have this squared term. So we have plus negative 2x squared, which we can just, adding a negative is the same as subtracting. So we'll just rewrite that as minus 2x squared. And then we have our x to the first terms here in red. So we have positive 3x plus x. So 3x plus 1x is 4x, and that's positive 4x. And then we can add together our constants. Negative 6 minus 2 is negative 8. So this would be that polynomial completely simplified using addition. So put a box around my final answer, and there you have it. Subtraction is just requires one more step than addition does. So when we rewrite this polynomial, we have to think of this minus sign as like plus negative, right? So we can change this to kind of like plus negative. So when we rewrite this, negative 2x squared plus x minus 2, the first one stays the same because there's no sign in front, but we have to distribute this negative to everything inside. Sorry, that wasn't the best arrow. Inside of the parentheses. So this becomes negative 3x, right? And then negative 4, which will be positive 4. I hope that kind of makes sense, right? Because we can also, I don't even like to think about subtraction. I really think about adding a negative, right? So if we distribute this negative to the negative 4, it becomes a positive 4. So you can kind of think of, well, you can always think of subtraction as adding a negative, and that'll help you decide what to do with the problem. So now that we've used our distribution of the negative for the second polynomial, now we can simplify using like terms just like we did before. So I'm looking for my highest degree. We have a term here that's squared, and that's the only one. We have an x term here and an x term here, remembering to keep the sign that's in front of the term with it. And we have two constants left, one there and one there. So when we simplify this, we can simplify this and put this in standard form all at the same time. We have a negative 2x squared that's not being combined with any other like terms because there are no other like terms. So then we have 1x squared minus 3x. Well, if we have one apple and we subtract 3 apples, we end up with negative 2 apples, right? Or you could say plus negative 2, right? But we always simplify adding a negative into subtracting, but you can always change subtracting into adding a negative. And for our constants in red, we have -2 plus 4. So -2 plus 4 will end up with +2. So this is our final answer for our polynomials once we subtract them. Put a box around my final answer and you are done.